Hello Math 140 students, this is your instructor Cindy Enrique and we are going to continue with chapter 7. Today we're going to go over section 7.2, which is the multiplication and division of rational expressions. And really it comes down to 3 steps. We just want to factor everything as possible. So you're going to factor the numerator and the denominator. We're going to multiply the numerators, then multiply the denominators together, and then you're just going to cancel out common terms. So let's go ahead and start. So I'm going to look at this as the first fraction and the second fraction. So this first fraction, I see this, and I'm going to just deal with this fraction first. So when I'm dealing with this one, I can see that the numerator can be factored. It has a GCF of 3. So there's 3. Now I'm going to be left with a y minus 2. Down at the bottom, I still have a 6 and a y. Now I'm going to deal with my second fraction over here. And remember, everything's being multiplied. And so I can think of this. And again, if you guys like to do the AC method, go ahead and do so. Do whatever you feel is necessary in order to factor. So here, if you're looking at it, my A was equal to 1, my B was equal to 3, and my C was equal to 2. Therefore, my A times C, 1 times 2 is 2. And I write down my B value is 3. So two numbers that multiply to 2 and add to 3 would be a positive 2 and a positive 1. And since the leading coefficient is 1, I know exactly what's going to be written inside those parentheses. So I'm going to have my y plus 2 and my y plus 1. Down at the bottom, I see that it's a perfect square, y squared, minus a perfect square. So down below, the denominator is a difference of squares. So I'm going to have a y plus 2 as well as a y minus 2 since they are conjugate pairs. So now I can see how everything is being factored. So up on top I have a 3. I have my y minus 2. And I also have the y plus 2 and the y plus 1. And the denominator, I have the 6, I have the y, and I also have the y plus 2 and the y minus 2. Okay. And then so from here, I'm going to cancel out my common terms. So I see that this y minus 2, I have it down there. And also the pair y plus 2 can also cancel out. 3 and 6, that's a fraction that can be reduced. 3 divided by 3 is 1. 6 divided by 3 is 2. So now I have what this is going to equal. So up on top I have the 1, and I also have my y plus 1. Down at the bottom, I have a 2 and I have a y. And nothing else can cancel. That's as far as I can go. So that is going to be my final answer. So I'm just factoring as much as possible. All right. So for number 2, it's the same process, okay? It's just a different polynomial to factor, but we're just factoring. Just factor as much as you possibly can. So, okay, so if I think of this first fraction, I have A is equal to 1, my B is equal to 8, and my C is equal to a positive 16. So I'm thinking about that numerator. And if I have my A times my C, 1 times 16 is 16. My B value is 8. So what multiplies to 16 and adds to 8? Well, that would be if it was positive 4 and positive 4. So now I know how that numerator is going to factor out. I'm going to have my P plus 4 and my P plus 4. And remember, the only reason I can do this is because that coefficient, even though you don't see it, is really a 1. Otherwise, I would have to do guess and check, or I would have to do the 4-term polynomial. Okay. Now, I'm going to look at my denominator. The denominator, I have a GCF. The GCF is 10. So if I factor a 10 out, I'm going to have P plus, well, 10 divided by 10 is 1. So make sure that you put that 1 there. Now, I'm going to look at that second fraction. That second fraction, it looks like I have a GCF. If I have 2P plus 6, well, 2 and 6 are both even numbers, so 2 goes into both of them. And then 6 divided by 2 is 3. So I have P plus 3. So down at the bottom, I know I'm going to have to factor that. And if you want to do the AC method to help you out, that's fine. I'm going to have that my A is equal to 1, my B is equal to 7, and my C is equal to 12. So I know I have A times C up on top, and I have my B value down at the bottom. So I have 7 on the bottom, and A times C, 1 times 12 is 12. So I know if I multiply a positive 4 and a positive 3, that's going to give me positive 12 and a positive 7. And because that leading coefficient, remember that leading coefficient A is equal to 1, so I'm able to write this as its factored form. So I'm going to have my P plus 4 and my P plus 3. Now you don't really have to rewrite it, but sometimes it just helps. And it's really up to you how you want to do it. So I'm just going to rewrite this. So I have my 2, I have P plus 4, I have P plus 4 again, and I also have that P plus 3. And down below I have 10, I have a P plus 4, a P plus 1, and a P plus 3. And remember, multiplication, you can rewrite it in any form, and it's still the same. For example, if I have 3 times 5, that's the same as 5 times 3. So multiplication is commutative. So it's okay to switch those numbers around. So now I get to cancel out some common factors. So P plus 4, that can cancel. The P plus 3, that can cancel. And 2 divided by 2 is 1. And 10 divided by 2 is 5. So now I know more or less how this is going to factor. Up on top I have a 1 if you want to write it. I have my P plus 4. And down at the bottom I have a 5, and I also have a P plus 1. And so that ends up becoming my final answer. Okay? So hopefully you've gotten a feel for multiplying these rational expressions. It's all about factoring, putting them together as one, and then canceling out together. Okay, now we're going to take that example and go into division. The only new thing with division is that you are going to get that second fraction and write it as a reciprocal. Okay, so what we're going to do, we're going to do this in order. We are going to copy the first fraction. So that's the one on the left. So that doesn't change. So okay, so I'm going to have my 8t to the 3 plus 27 all over my, and over here I'm going to rewrite this in standard form. So I would have a negative 4t squared plus 9. Okay. So I did the first step. I copied the first fraction, the one that's on the left. Then I'm going to change this division sign into multiplication. Division is just the opposite of multiplication. And then I'm going to write the reciprocal of that second fraction, the one on the right. So now I'm going to write on top 2t squared minus t minus 3. Down at the bottom, I'm going to have a 4t squared minus a 6t plus 9. So now my setup is there. Now I do the exact same thing as if it were multiplying. So, okay, I know that up on top I need to have to factor, And I need to see that it's degree 3, so this is going to be a sum of cubes. So something to the third power minus something to the third power. And over here, I can see that if I were to have written 2t, 2 times 2 times 2 is 8. So now we're going to look at that 27. What number multiplied by itself 3 times gives me 27? That would be 3. Perfect. And down at the bottom, I need a GCF. Well, notice how that leading coefficient is negative. When your leading coefficient is negative, you always want to pull out a -1. So then I'm left with a 4t squared minus 9. And now this makes my factoring a lot easier. Now I know with my formula for the difference of cubes, oh, and my apologies, this was a addition sign. That's addition, so I should keep it consistent. So this should be addition as well. So make sure you copied on the same sign. So I'm going to have my 2t plus 3. Then it's going to be square the first thing. So 2t times 2t. 2 times 2 is 4. T times t is t squared. And then I'm going to multiply the 3 and the 2 together, so that's a 6t. And then always positive, 3 times 3 is 9. Okay. And down at the bottom, since it's a difference of squares, the square root of 4 is 2. And the square root of 9 is 3. So then I write the conjugate pair, which is 2t minus 3. So all I did was work with the blue fraction first. Now I'm going to be writing with my green fraction second. So up on top, I know that I want to factor this thing. So in the numerator, I'm going to have to try this. So I'm going to have a 2t and a t. Now let's think about this. If I were to put the 3 here, when I go back and FOIL it, 2 times 3 is 6, which is way too big. So I know that the 3 can't go there. So that means the 3 is going to have to go here, and the 1 goes there. So now I have my 2t squared, that would be the first, my outer, which is 2t, my inner, which is 3t, and you want the bigger value to be negative since the middle was negative. And negative 3 plus 1 is negative 3. And down at the bottom, see how I have that 4t squared minus 6t plus 9? Well, that looks very, very similar to what I have in my blue numerator, so I'm going to rewrite it. So I'm going to have my 4t squared minus 6t plus 9. So all of this is being multiplied together. So I have my 2t minus 3, and I have my t plus 1. And down below I have my 4t squared minus my 6t plus 9. And everything is being multiplied. So now I can just cancel things that are very similar. So this 2t plus 3, that's there. And I have this long trinomial that cancels with that trinomial. And I have the 2t minus 3 also cancel out. So now I'm going to write everything that survived. So in the numerator, the only thing that I see is a t plus 1. And in the denominator, the only thing that I see is a negative 1. So I'm okay with writing it like this. Or you can write it, sorry guys, I'm trying to get a new pen this week, technology. Or you can write it as a negative 1 t plus 1. Both ways that are written I would accept for full credit. Okay, hopefully you guys are getting very, very comfortable with the whole factoring now, okay? Whether it's the AC method or guess and check or whatever method that you're using, make sure that you're doing something that works well for you. That's the most important thing. All right, so for number 2, it's the same process, okay? We are just going to keep factoring. So my first fraction, I'm going to write it down. So x squared plus x over 5x cubed minus x squared. I'm going to change that division into multiplication. Then I'm going to flip that second fraction. So I'm going to have my 25x squared minus 1. And down the denominator, I will have a 10x squared plus 12x plus 2. I don't know what it is, but somehow if you just have your setup right from the very start, you're less likely to make a mistake later. So with my blue fraction, if I were to factor that numerator, I'm going to pull out a GCF. So they both have an x in common. So I'm left with an x plus 1 in the numerator. Down below, they have an x squared in common. That's the GCF. So I'm left with a 5x minus 1. Now I'm going to be dealing with my green fraction. My green fraction, that numerator, the perfect square root of 25 is 5. The square root of 1 is 1, so that's a difference of squares. So I'm going to have my 5x plus 1. Now I'll have my 5x. Remember, it's the conjugate pair, so the opposite of addition is subtraction. So one's addition and the other one's subtraction. And so the denominator, I have 10, 12, and 2. Just by looking at it, I know that I have a 2 in common. So I'm left with a 5x squared plus a 6x plus 1. I'm not sure if I can factor more. I'm going to try. So let's see, 5x times x is 5x squared. The only way to get 1 is 1 times 1. And let's see what happens when I add everything together. That would give me a 5x squared, a 5x plus a 1x is 6x plus 1. So it does factor further, okay? So I'm going to rewrite this fraction. So that blue fraction, I had the x, and I had the x plus 1. And I had my x squared and the 5x minus 1. And my green fraction, I had the 5x plus 1 and the 5x minus 1. And down below, I had the 2 and the 5x plus 1 and the x plus 1. So now everything is as factored as possible. So now I start to cancel things off. So I have an x plus 1 that cancels out with that x plus 1. I have a 5x minus 1 that cancels with that 5x minus 1. I have 5x plus 1, which cancels with 5x plus 1. And so I'm going to rewrite this. What I see up on top is x. And down the bottom, I have an x squared times 2. So I like to write it as x over 2x squared. But now, hopefully you guys see that I have something else to cancel. I can cancel out that x and the x squared as well. So just to see it visually, up on top, I have one x, and down at the bottom, I actually have two x's. So what ends up happening is that this x cancels with that x, but you're still left with an x on the bottom. So I have 2x on the bottom. So with everything canceled in the numerator, what do you have as a default answer? Hopefully, you guys are all thinking 1. If everything cancels out in the numerator, then your numerator defaults to be a 1. So your final answer is going to be 1 over 2x. Okay. So down below, we have some practice problems. So we have practice problems 1 and 2. We have a few. So this is where you guys are going to press pause on your device, whatever you're listening this to, and you're going to work out the problems. And I will show you all the worked out problems. So now press pause. Okay, well, I hope you guys had pressed paused and worked out the practice problems, because this is where you guys actually get the practice. So for number 1, I factored it and I combined like terms, and then I canceled out common terms, and I got my final answer as 2/3. For number 2, same thing. I just factored everything, and I got my final answer as x times 2x minus 3. And in the denominator, y squared x plus 1. And what you might notice what I'm doing is I actually highlight it, because when I'm not talking out loud and I'm doing this work by myself at home, I find that sometimes I kind of miss things. So when I highlight it, I know that those are things that I need to write in my final answer. And I just kind of use that as a habit, so I know that I need to write that at the very end. It's sort of like a little reminder to myself. Number 3, this one was division, so I copied, I times it, and I flip it. So remember, whenever you have the division, you should be thinking copy times flip. So with division, think copy times and flip. Okay. And then I canceled everything out, and then I highlighted everything that still stayed, and I wrote that as my final answer. Having 1 in the denominator is fine. If you don't want to write it, that's fine too. So I'm okay with both of those answers. For number 4, I have division again, so I did the copy times flip. So I factored as much as possible, and I got my final answer, and I highlighted what I want in my final answer. And for number 5, this one got a little bit tricky because now I'm dealing with 3 terms. So I did a division, so I copied times flipped that one, and then that third fraction is being multiplied, so I kept that as being multiplied. And then I factored everything out, and then I canceled it, and then I highlighted everything that was left after canceling. And for number 6, that last one here, same thing. I copy the first 2 fractions down. I changed that last fraction from a division into a multiplication, but when I did that, I remembered to flip the fraction, or rewrite it as a reciprocal. And then now that everything was factored as much as possible, I started canceling out terms. I noticed that I had really big numbers, 45, 4, and 2, and 27 down at the bottom. So what I ended up doing is just canceling out the numbers before I made them bigger. So I knew that 45 and 27 were both divisible by 9. So 45 divided by 9 is 5, and 27 divided by 9 is 3. And then I have 5 times 4 times 2 in the numerator and 3 in the bottom. There's no common terms, so I just multiplied it out. So 5 times 4 is 20, 20 times 2 is 40. And you still have the 2x plus 1, and then in the denominator you have that 3. Alright, well, hopefully this was helpful for you guys. And if you have any questions, please email me. Thank you.